Can a robot follow a line without a microcontroller? The answer is yes. After watching this tutorial, you will be able to design and build a line following robot without using a microcontroller. By the end of this video, you will have a comprehensive understanding of how to build a simple yet effective line following robot using the LM358 Op-Amp and analog circuitry. This tutorial will be divided into two parts. In first part, I will describe the components and the circuit. In the second part, the implementation of circuit on the breadboard and calibration. So without further ado, let's get started. Before going to the circuit, here are the components we need to build a prototype of robot car. We need two pieces of N20 Gear Motors. These are 100 RPM motors that works fine with 3 volt to 6 volt. We need two pieces of 3 pi mini Q car wheels for N20 Gear Motors. A ball caster wheel, two motor mount bracket for N20 motors, a screwdriver, wires for motor connections, and we need a piece of foam board. Now let's start making a car prototype. You can make it as you like. I would go with a simple rectangular chassis. Mount two N20 motors for the rear wheels. Then mount the ball caster wheel at the front middle. After that, we need to connect the motor wires. Here I cut two pieces of male-to-male jumper wires in half. I'll keep the male pin on the upper surface and later we'll connect to the breadboard. On the bottom, I'll solder the wires with the motors. After finishing the soldering using a 3.7 volt battery, we can check the positive and negative wires for the forward rotation of the motors. Remember which wire is positive and which wire is negative for the next connections. Now let's design the circuit. This is a symbol of comparator. In electronics, a comparator compares two input voltages and outputs a binary signal indicating which is larger. If the non-inverting input is greater than the inverting input, the output goes high. If the inverting input is greater than the non-inverting input, then output goes low. An op-amp, that's mean operation amplifier, can be used as a comparator. The LM358 is a dual operational amplifier, integrated two circuits that feature two independent op-amp circuits in a single package. The LM358 has 8 pins. Pin 1, op-amp 1 output. Pin 2, op-amp 1 inverting input. Pin 3, op-amp 1 non-inverting input. Pin 4, ground. Pin 5, op-amp 2 non-inverting input. Pin 6, op-amp 2 inverting input. Pin 7, op-amp 2 output. And pin 8, VCC, that means positive power supply. At first we will add 3.7 volt to the pin 8 and ground to the pin 4. Then we will make the right front sensor for the line follower. We will use a light dependent resistor, which is LDR. When light falls on the LDR, its resistance decreases. One side of the LDR will be connected to ground and the other side will be connected to the voltage source after a 1K resistor and a 10K potentiometer. Here the potentiometer will help us to adjust the sensitivity. The LDR is used in a voltage divider circuit to detect the line. We'll use a LED beside the LDR. A 47 ohm resistor will protect the LED from overflowing current. The LED light will reflect from the surface. To make the LED light more stable, Here we can use a 100 microfarad capacitor in parallel with the LED. So this portion is work as a right sensor. Like the same way we will make the left sensor. We will take the voltage from the right side sensor and connect it to the pin 6 and 3 of the LM358. By the same way, we will take the voltage from the left side sensor and connect it to the pin 2 and 5 of the LM358. Now let's come to the output. We will use two BC547 transistors. Here the transistor will act as a switch, turning the motors on and off based on the signal from the op-amp outputs. We'll use a 10 ohm base resistors. Connect the motor positive terminal to the positive voltage and the negative terminal to the collector of BC547. Connect the emitter of BC547 transistor to the ground. A black line on the surface will reflect less light. When the LDR detects the line, its resistance increases, cause a voltage increase. The voltage increase is processed by the op-amp to determine the line's position. Based on the LDR signals, the robot's motors are controlled to move left, right or straight. Now let's build the circuit on a breadboard. I will use a 400 points breadboard and some jumper wires. Place the LM358 on the middle of the breadboard. Keep the IC notch on the left side. We'll start counting pin numbers from the bottom left. We will use both upper and lower power rails from the same source, so we are making a connection between them. To power up the IC, connect pin 8 to the positive rail and pin 4 to the ground rail. Now we will make the right sensor. Here the LDR. I will place it on the breadboard. One leg of LDR will be connected with ground. From the other leg, in series with 1K resistor and then a 10K potentiometer will be connected with the positive rail. Then I will add a white LED, connecting cathode of the LED to the same ground I used for LDR. And the anode terminal of the LED will be connected with a positive rail through a 47 ohm resistor. Then 100 microfarad capacitor will be placed parallel to the LED. With that, making the right side sensor is done. We'll do the same process for the left sensor. Now from the right sensor, take the node voltage between the potentiometer and the right LDR to the LM358 pin 6 and 3. By the same way, from the left sensor, take the node voltage between the potentiometer and the left LDR to the LM358 pin 2 and 5. Now we will take the output for motors. The first output from pin 1 will go to the base of BC547 transistor through a 10 ohm base resistor. Instead of motor, we will test with an LED. Later, we will replace the LED with a motor. The LED anode will connect it to the positive rail and the cathode will be connected with the collector of BC547. The emitter of the transistor will go to ground. The second output from pin 7 will go through the same circuit for another motor. As a source of voltage for the circuit and motors, we'll use a 500 mAh lithium battery. To know about the TP4056 charger controller, you can watch my previous video. So after connecting the battery to the positive and negative rails, let's see. Yes, the LDR sensors are working fine. Now I will place the breadboard on the car chassis and replace the LDR with the motors. At final, I will place the pair of LDR and LED on the bottom of the robot on each side of the center line. To take the sensor from the breadboard to the bottom of the robot, I have to use some wires. Here you could see I am soldering some wires that I will connect exactly to the same point it was on the breadboard. This setup allows the LDRs to detect the line on the floor, illuminated by the LEDs. So here my line followers robot is ready to run. Let's charge the battery first. When I tested it for the first time, I found that I connected the motors to the wrong side. Then I corrected my design and reversed the motor outputs. This is the final result. Thanks for watching. Share your thoughts and experience in the comments. I appreciate your love and support for my channel.